Ladies and gentlemen, here we go. We are starting volcanoes. All right, we talked just a little bit about it in class yesterday. Today we're going to really begin to dive into our little mini unit here on volcanoes. So we're going to start with a little bit of an introduction and kind of a review as well. So we've talked in the past about the layers of the earth, and so we know that the earth's crust is made up of solid rock. It's not liquid, but it is solid and cool compared to the inside of the earth. And yet, despite this, most of the earth, the interior that is made up of extremely hot rock, the mantle. We've talked about that before. And then we have liquid metal in the core of the earth. All right. And then we have occasions when this heat that is inside the earth actually escapes to the crust and even outside of the crust. And that, of course, would be known as a volcano. So volcanoes are happen because the Earth's crust is not completely solid. There are actually weak spots in the Earth's crust and cracks and fissures and all of those fun things. And in these weak spots, molten magma can come up through the crust. Along with rock fragments can also come up through, and very hot gases can come up through there as well. And this combination of magma and rock fragments and hot gases cause an eruption. A mountain that's been built up from all of this erupted material, material that's come up through the weak spots, that is our volcano. Mount Hood, I don't know how many of you are familiar with Mount Hood, but it is located in Oregon, so on the west coast of the United States. And Mount Hood is a volcano or volcanic mountain. Not too far from Mount Hood, also in Oregon, is Mount St. Helens, and perhaps you've heard of Mount St. Helens before. And it actually erupted in my lifetime back in, I believe it was the early 1980s. So, so we do have volcanoes, not just volcanoes in the United States, but not just in Hawaii. We have them in other places as well, mostly along the west coast, mostly along Alaska, and down through Washington, Oregon. There are some other places where scientists believe there are some dormant volcanoes as well. Let's take a look at the patterns of volcanoes, because generally speaking, we can identify where volcanoes are located. We cannot always identify when they're going to erupt, but we can identify most of their locations because they tend to occur along these belts along the Earth or along the Earth's crust. And these belts occur or happen along convergent and divergent plate boundaries. Of course, the picture on the left is a convergent plate boundary, where the plates are converging upon one another or colliding into one another. And then divergent is on the right, where they are where the plates are dividing or moving away from each other. Both of those areas allow magma to be able to rise to the surface because they create these fractures or ridges or breaks in the crust. When two plates converge or run into each other, typically one will subduct under the other one. Usually oceanic crust subducts underneath the continental crust, and when that happens, the one that goes down underneath, the one that subducts, that crust starts to go down into those hot layers and the crust starts to melt. But also, along with it, some water kind of seeped down there because of the ocean water above this, and that water causes it to kind of superheat and get all extremely pressurized down there, and volcano will happen. And then in a divergent plate boundary, you have the two plates pulling apart, and then the magma comes up into that crack that has formed. We're going to take a look at a couple of maps here. This first map just shows some of the tectonic plates on the Earth's crust as far as scientists are aware. And then this next one takes a look at where most of the volcanoes in our world are located. And you'll notice an awful lot of them are located right along these plate boundaries. All right, you've heard me talk in class the other day about the Ring of Fire. Well, the Ring of Fire happens to be a place on the Earth where 80% of the world's volcanoes are located. It's a belt of volcanoes that basically goes around the Pacific Ocean, not the southernmost part of the Pacific Ocean, but all of the rest of it. We'll take a look at a map in just a moment. The ring is basically a whole bunch of convergent plate boundaries where the Pacific plate, the plate that makes up the bottom of the Pacific Ocean basically, is subducting below a bunch of continental plates. And so here is a little bit more detailed drawing of what I was talking about before, where we have this oceanic crust subducting or going down underneath the continental crust. And when that happens, there can be a little gap there and some water can seep down in there. As it sinks down, the crust begins to melt with the water seeping down in there with it. The water starts to boil and things and just makes things that much more almost furious, kind of, so to speak, and it gets to the point where there's so much pressure built up down here from all the heat and all the gases building up that the volcano ends up erupting up through that area, and you end up with these volcanic mountains. Here is a map that shows the Ring of Fire. So again, these these triangles represent volcanoes all around this area that we know of as the Ring of Fire. Okay, and so it starts down here in New Zealand, comes up through Oceania. Here we have Indonesia, up through the Philippines, up through Japan. Japan has so many volcanoes. Up through part of Russia, over to Alaska, down the west coast of the United States, down along through Mexico and Central America, and along the western coast of South America. And here's just another map showing the Ring of Fire as well. All right, so we're going to take a little bit of a look at the anatomy of a volcano, so to speak. So down underneath the volcano is the magma chamber. And then the tube, so to speak, that goes up through the land that the magma ends up coming up through, that is known as the pipe. At the top you have the crater where a lot of landmass kind of blows off when there's eruption. You can also have almost like little mini pipes breaking off from the main pipe, and when that happens you end up with these vents in the side of the volcano. And then, of course, as the magma exits the volcano, it becomes known as lava, and the lava that flows down the side of the mountain is known as the lava flow. Up above the volcano, in most cases, you're going to end up with an ash cloud, because it's not just magma that comes out of that volcano, but there's also dust and rocks and things like that as well, and ash. And there you have the rock fragments that are being blown out when that crater forms, and this piece of land up here kind of gets blown into smithereens, so to speak. All right, so some of the materials that we want to talk about when talking about volcanoes. First of all, we talked about this in class the other day too, the fact that magma and lava are technically different. So they are made of the same material, and lava was once magma. However, they're considered to be different. So it's lava when it is liquid rock that is at the Earth's surface or on the Earth's surface. Magma is the liquid rock that is below the Earth's surface. And there are different kinds of lava. Now, in the English language, we basically have one word for lava. That would be lava. However, in places in the world where they have a lot more volcanoes than what we have in most English-speaking parts of the world, they often in their languages have several different words to mean different kinds of lava. So we're going to take a look at a couple of the more well-known types of lava. And these are going to be Hawaiian words that we're learning today, because the Hawaiian language has, I think it's at least 7 different words for lava to describe different kinds of lava. So the first one we're going to talk about is a thick lava. It's called a'a, spelled A-A, a'a. All right. And then the second one, which is a much thinner, more liquidy lava, is pahoehoe. All right, pahoehoe. So here is a picture of some of the a'a, or the thick lava. It's very high in what we call silica, which is basically a mineral. It flows really slowly because it's really thick. And so because of its slow movement and its thickness, it has very explosive eruptions. Think about for just a minute, if you had a glass of water and you had a glass that had milkshake in it, okay? If you take a straw and you put it in the glass of water and you blow, you're going to get some kind of eruptive qualities as the air bubbles come up to the surface. If you blow into the milkshake with a straw, it's going to take a little more effort to get those bubbles to come up to the surface, but when they do come up to the surface, they become very eruptive. If you have a chance to get a milkshake in the next few days and you don't mind wasting a little bit of it and your parents don't mind a little bit of a mess, feel free to try that. Most mountains that tend to have eruptions that have this a'a lava tend not to have eruptions too frequently. One example would be Mount St. Helens, which is the one that erupted in the 1980s in Oregon. And then you have the thin pahoehoe lava that can tend to spew high in the air because it's not quite as heavy and thick. And it tends to be very low in this mineral of silica. It flows very easily, much more water-like, at least compared to the a'a. It has what we would consider much weaker eruptions. Keep in mind that doesn't necessarily mean they're not destructive, but they seem weaker to us. And they do tend to erupt much more frequently. And one example would be Mauna Loa in Hawaii, which Hawaii, of course, is made up of volcanic mountains. Mauna Loa is perhaps the more well-known one. And then we're going to take a look at a couple of different kinds of volcanoes. Well, actually, I think we're going to stop there. I think we'll come back to types of volcanoes next time. You're actually going to start to take a look at types of volcanoes today in your interactive. So we're going to take just a moment and we're going to take a look at that interactive real quickly. So this is the website that you're going to be going today. When you get there, you're going to click the launch button. That will probably open up another window or at least take you to a new thing. And this right here is what you are going to be working with. So you're going to read this introduction here, and then you're going to come down underneath the picture. And the only part of this that you're going to deal with today is types of volcanoes. So you're going to click on types of volcanoes. You're going to read this information right here, and you are going to go ahead and write down a couple of facts from that. Then you're going to go to the cinder cone, and that will open up another window. And you're going to read about the cinder cone. When you see a next button here, it means there's a little bit more information. So you're going to write down a couple of facts there, and then click on formation. And that will open up another window. We'll see if we can enlarge that window just a little bit. And you can kind of click through here and see how these cinder cones kind of how they're produced and how they form. Read about that as you go. And again, write down a couple of facts that you learn along the way. And you're going to do that for each of these. All right. Click on formation and kind of go through and make sure that you read this information, ladies and gentlemen. Clicking is so much fun, but doesn't do you a whole lot of good unless you actually kind of do some reading. So make sure that you read and write down a couple of facts that you learned along the way. You're going to do that for each one. So I think hopefully you have the idea here of what you're doing. Don't forget, if you see a next button, to click that. All right, so ladies and gentlemen, I hope you have a great day. We'll talk again later. Have a good day.